Hello everyone. Today's topic is electric potential and potential difference. Let's take two like charges A and B. There is a repulsive force between them. If I want to move this charge B towards charge A, then some work has to be done against repulsive force. Next, let's take two unlike charges. There is an attractive force between them. If I want to move this charge B towards charge A, then the work will be done by the attractive force itself. Some work is always involved in moving a charge in the vicinity of another charge. This work divided by the amount of charge is expressed in terms of potential. So let's now understand the definition of potential at a point. This is a cluster of positive charge. I want to define potential at this point. Let's first understand the term infinity. For this cluster of charge, there will be a definite filled area within which the force due to these charges will be acting. If I am keeping a positive charge or a negative charge within the field of these charges, then the positive and negative charge will be experiencing the force due to this. But what if I keep those positive or negative charges beyond the field of these charges? Then the force will be zero. That distance is called as infinite distance for this cluster. So now I am taking a unit positive test charge at infinity. Now I want to move this positive test charge from infinity to this point. Then some work has to be done. This work done divided by the amount of charge will give you the potential at that point. Next, we have taken cluster of negative charges. I want to define potential at this point. So again, I have taken a unit positive test charge at infinity. I want to move this positive charge from infinity to this point. So work has to be done on it. Work done divided by how much charge I have moved. That much will be the potential at this point. The definition is the potential at a point is defined as the amount of work done per unit charge in bringing a positive test charge from infinity to that point. Now let's give unit to electric potential. So looking at the formula, we will give unit. Work is measured in joule. Charge is measured in coulomb. So joule per coulomb is the unit of potential. But scientist Alessandro Volta did lot of inventions in this term. So in honor of that scientist, potential is given unit volt. Now looking at this, it is very clear. 1 volt is equal to 1 joule upon 1 coulomb. And even we can define 1 volt looking at this. See how. When 1 joule of work is done in moving 1 coulomb of charge from infinity to a point, then potential at that point is said to be 1 volt. Now let us understand the concept of potential difference. Basic concept of potential difference we will understand by taking two cases. First case, I have taken empty vessel. In that I have kept two electrodes, connected a bulb in between the two electrodes with the help of a wire, right? My question is, will the bulb glow? Now let's discuss second case. A vessel, same two electrodes, bulb connected with a wire, but this time now I am feeling electrolyte in this. Again my question is, will the bulb glow? In this case, answer is yes, bulb will glow. The reason is the presence of electrolyte helps this electrodes gain positive and negative charges. Due to this, potential difference is created and potential difference is responsible for flow of current. Whereas in this first case, there was no electrolyte present, so there were no charges on these two electrodes. There was no potential difference between them, so current was not flowing and bulb was not glowing. Now let us understand the actual concept of potential difference. I am taking any 2 points A and B of a circuit. Now I want to move this unit positive test charge from point B to point A. Consider W is the work done in moving this test charge from B to A. Then potential difference between points A and B will be equal to VA minus VB is equal to work done per unit charge. So potential difference between 2 points is defined as work done per unit charge in moving a unit positive charge from one point to other. So definition of potential difference is potential difference between 2 points is equal to work done per unit charge in moving a positive test charge from one point to other. Now let's discuss about the measurement. Potential difference can be measured by an instrument called as voltmeter. But the condition is voltmeter is always connected in parallel. Now the question is potential difference a scalar or a vector quantity? Answer is, it is a scalar quantity. Reason for that is, work is scalar, charge is scalar. So ratio of two scalar quantities gives you a scalar quantity. So potential difference is a scalar quantity. Let's give unit to potential difference. Work is measured in joule, charge is measured in coulomb. So joule per coulomb is the unit of potential difference. But potential difference is also given as unit volt. Let's define 1 volt. So when 1 joule of work is done in moving 1 coulomb of charge from one point to other, then potential difference between those 2 points is said to be 1 volt. So when 1 joule of work is done in moving 1 coulomb of charge from one point to other, then potential difference between those 2 points is said to be 1 volt. Thank you.